Hello and welcome back to episode 2 of the Stone Reform podcast series. Today I'm joined by Matthew Davies, who is going to speak to us a bit about the quarrying process in the UK today. How are you doing, Matt?
I'm doing good. I'm the resident quarry expert for the Stone Reform.
So do you want to start by, start right from the beginning. What is a quarry and what do we use quarries for in the UK?
A quarry is a designated excavation site where natural resources such as rocks, minerals, stones, sand, gravel, or any other geological materials are systematically extracted from the Earth's surface or subsurface. So this process typically involves the removal of these materials for construction, industrial, or decorative purposes. And these quarries vary in size and location all over the world, but focusing on the UK, the different typologies are a hillside quarry, a hilltop quarry, a coastal quarry, a valley bottom quarry, and each of these different quarries are chosen based on the deposit of stone in this location.
Very interesting. Currently in the UK, what are quarries used for?
So sadly, we've moved away from the use of stone on the most part in the UK, as most of the quarries in the UK are currently used to produce cement. So there are many different quarries in the UK quarrying these different stone types. Some of these include, but are not limited to, sandstone, granite and clay. However, the majority of these quarries are currently in operation to support the production of cement, providing aggregates and sand for mass concrete production.
Interesting. So there we've got a mixture of sedimentary and igneous rocks, haven't we?
Yeah, so breaking them down into the two different processes, starting with the sedimentary rocks, as they involve different processes due to the different different qualities of the different stones. So initially, a face survey is carried out on the face of the quarry wall to assess the quality of the stone. Shot holes are then drilled into the top of the quarry wall and filled with explosives before stemming the top. So this stops the explosives from exploding out through the top of the hole. These explosives are then detonated through a controlled explosion, creating a shot pile, which is a pile of rocks, ready for loading. These rocks are then transported to a crushing facility where they are systematically fed through a primary crusher, a secondary crusher, and a tertiary crusher to reduce the material to a finer size. These are then loaded onto trucks and then delivered to customers or storage facilities.
So just to make it clear, is that process for quarrying stone for stone structural use, or is that for cement? What is that?
Mostly this is for cement as of current, to produce these small aggregate chunks which are used in the production of cement.
So we're seeing that in these sedimentary quarries, we're seeing the structural stone is being chopped up into tiny little bits to be made for cement. Is that right?
Yeah, that's correct. Yeah.
And is that happening also with igneous rocks?
The quarry in a completely different way, to be honest. For a igneous rock quarry, the top of the quarry, vertical shafts are drilled using diamond-tipped drill bits.
So less of a obtrusive method compared to basically blowing up.
Yeah,
the rock.
Basically a diamond-tipped saw blade is fed through here, which cuts through the igneous rock systematically, producing larger chunks of this stone rather than obviously blowing up into smaller chunks like the other process, sedimentary process.
That's brilliant. And generally, are we seeing these larger chunks in our buildings, or are they being split up into cladding materials? What are we seeing?
Yeah, as of current, we're not really seeing that. Currently, they are only being used for cladding materials, which is quite sad, really, because we've moved away from that over the years.
And then, in terms of the production of cement for concrete, is there anything that you'd like to talk about in terms of that?
Yeah, so as I've explained previously, the process of producing concrete takes a lot more processing facilities, and it's a longer process, and each of these different facilities need to work hand in hand with one another to produce the final outcome. So as I've mentioned previously, on the sedimentary rock quarry, these aggregates are transported to a facility where they are passed through a raw mill before being fed into a preheater and kiln. This material is then processed further using a clinker before grinding to produce a cement.
So if I'm right in thinking, isn't there lots of different materials that goes into concrete, and are these materials also quarried?
Yeah, there's about 7 or 8 different stone types which are involved in the production of cement, and each of these different stone types are quarried all over the UK.
Brilliant. So at the moment, we're seeing sort of about 7, 8 different quarries to make one material. That, if I'm right in thinking, is a lot weaker than the stone that it's being created from in the first place, isn't it?
Finished stone product has a higher compressive strength than concrete, as well as a higher stiffness, which this is an incredible increase. This is an 80% increase over concrete, specifically for basalt. And the stone also has a higher service temperature than concrete, as well as the ability to be 100% recycled at the end of use. So as you can imagine, the benefits of using stone far outweigh that of using concrete.
Really interesting to see. And what would you say the embodied carbon of stone entails? What is within it, and how can we reduce that embodied carbon further?
Yeah, so currently in the production of this stone, fuel is used in these different facilities and the machinery, but we could be using renewable energy to produce this stone. That would be a starting point.
But the actual extraction obviously takes a certain amount of energy and the transport, but the material itself basically has no carbon, does it?
Yeah, no, technically it's been coined that stone is zero carbon. Obviously a stark difference to that of concrete, which is known as one of the most carbon intensive materials that you could possibly use.
Brilliant. Well, that's everything that we would like to talk about in terms of quarries. Thank you very much for joining me today, Matt.
Thank you for having me on.
See you soon.
Bye now.